Hello, we are going to work through every single problem on the review here. Starting off with number 1, when it says use a sum or difference formula to find the exact value. We have our sum and different formulas, particularly for A, we have sign sum and sign difference. Our goal is to find an addition or subtraction of 2 unit circle rotations that add or subtract to be 195. So my suggestion would be, I'm going to list a couple of them and then I'll go ahead and work through one of them. So my suggestion would be looking at 195 and going, okay, well, what are my unit circle rotations? I have 30, 45s, and 60s. Well, if I have a 95, it ends in 5. That's suggesting that we're going to need a 5, obviously, for our single digits for one of our rotations, meaning we're going to need a 45. So I'm going to, because 135 is our second quadrant, 45, that's pretty close to 195, so I'm just going to try that and then say, oh, well, I need to add 60 to that in order to make that 185, so that would work. Well, what if you tried 225? Well, that's after or post 195, so we're going to have to subtract something, and that would be a subtraction of 30, so that would work as well. On previous videos, I have typically done a problem that looks like that. So in this one, I'm going to try this one. I'm going to do the sign difference one. So if we do sign difference, the formula goes sine of alpha, first angle, times cosine of beta. In this case, beta is 30 degrees. And then minus cosine of alpha, in this case, our first angle is 225, times sine of beta, which is 30. Now we have all of our unit circle calculations. I like writing the parentheses here, so that helps me remember that we just want a ratio out of this. We just want like a root 2 over 2, negative 1/2, and so on. We don't want sine root 2 over 2 or cosine root 2 over 2. That's the most understandable but mistake that students make within this section. So I'll talk through these. 225 is a 45-degree rotation in our third quadrant. So I go to sine y value at a 45 is root 2 over 2. And we're in our third quadrant, so it'd be negative root 2 over 2 since sine is negative in our third quadrant. Remember, it's not sine negative root 2 over 2, it's just negative root 2 over 2. Cosine 30, that would be the x value to 30 rotation, which is root 3 over 2. Cosine 225 is another 45-degree rotation in the third quadrant. Cosine is the x value, which is root 2 over 2 for a 45, and it's in the third quadrant. Cosine's negative. And then sine 30 is 1/2. And now I go ahead and simplify it. For the first part, I'm going to multiply these. That would give us negative root 2 times negative root 3, so it would give us negative root 6. 2 times 2 is 4. And the second part, I have 2 negatives, so that would turn positive. Root 2 times 1 is root 2, all divided by 2 times 2 is 4. Now, when I combine those, I put it all over the denominator, and I have a negative root 6 and a positive root 2. I am going to reverse the order, not necessary, but I'm going to reverse the order so that the positive term is first, and we end up getting root 2 minus root 6 over 4. Next, we have sine 15. Here, we're going to have to use subtraction, and in this case I'm going to go 45. Since I do have that 15 again, I'm going to try my 45, and then subtracting 30 will work. So now when I set it up, sine of alpha, cosine beta, minus cosine alpha, our first angle 45 times sine beta. This one's very, very similar to the one we just did, except in fact I think it's going to be easier. So it just, since we have rotations, this is the first quadrant. Sine 45 is root 2 over 2. So again, my parentheses, I have root 2 over 2. Cosine 30 is root 3 over 2. Then I go cosine 45 is root 2 over 2, and then sine 30 is 1/2. First fraction when I multiply gives us root 6. 2 times 2 is 4. And then we have, I'm going to go plus, I'm going to put the negative in the numerator, root 2 over 4. I could have just made it minus root, the whole fraction. So 6 minus root 2 over 4 when I combine it. And note, whenever we have these sum and difference utilized for sine or cosine, we get this like root 6, root 2 over 4 type structure. All right, moving on to tangent 5 pi over 12. So now when we're dealing radians, I want to find two angles that add up to 5 pi over 12. If we look at any pi over 12 that reduces, this is just a quick note on pi over 12s, any of them that reduce, 2 pi over 12, 3 pi over 12, 4 pi over 12, and we go on and on and on. I'll just do this verbally to make this relatively quick. 2 pi over 12 will reduce to pi over 6. 3 pi over 12 reduces to pi over 4, and 4 pi over 12 reduces to pi over 3. If you look at all of those all reduce to unit circle rotations that work for us. And that holds for all pi over 12s. Any pi over 12 fraction that reduces will reduce to a unit circle rotation that we can use, the pi over 6, pi over 4s, and pi over 3s. So our goal then, when we do this problem, is to get an addition or subtraction of 2 pi over 12 rotations that reduce. So you want to look for two numbers that add to be 5, and if those two numbers are divided by 12, it will reduce to a unit circle value. I'll give you an example. If I do 2 pi over 12 plus 3 pi over 12, that would reduce to pi over 6 and pi over 4, which are both unit circle values. Another way you could do it would be 8 pi over 12 minus 3 pi over 12. And both of those reduce, and therefore would give you what you need in terms of calculating. So I'm going to go with the first one, tan pi over 6 plus pi over 4. I know right now that the pi over 6, tan pi over 6 calculation is going to be kind of a pain because it's going to be 1 over root 3 or root 3 over 3. But nonetheless, we'll still go through this. Excuse me. So equals, I'm just moving to the right-hand side, equals, we use our tan sum formula, which would be tan pi over 6 plus tan pi over 4, 1 minus tangent pi over 6 times tangent pi over 4. Sorry if there's any background noise. So tan pi over 6, that's saying what's the y over x at or y numerator over x numerator at a pi over 6 rotation, which is, I'm writing it over here on the right. Root 3 over 2 comma half, so if I go y numerator over x, that would give us 1 over root 3. I'm not going to rationalize that because I'm going to have to get that radical out of its denominator anyways. Plus tan pi over 4, right here, tan pi over 4, that's root 2 over 2, comma root 2 over 2, so y divided by x is 1, over 1 minus, what's nice about this is it's just a multiplication of those two. So 1 over root 3 times 1 is just 1 over root 3. Now at this point, you want to get the radical out of the denominator, but we also have something else going on here. We have this fraction in a fraction which we call complex fractions, and the way we handle that is we find the denominator of each of the small fractions, the LCD of it, and then multiply the large fraction top and bottom. And when we do that, that LCD lines up with the numerators of the smaller fractions. What do I mean by that? If I look at this denominator, 1, 2, 3, 4, the denominator of this is root 3, the denominator of this is 1. Note, as a fraction, this would be 1 over 1. Denominator. The same would be 1, this would be root 3. So our LCD is root 3. So what I'm doing is I'm multiplying the large numerator top and bottom by root 3 over 3. And note, you could put this over 1 to help you see that it's lining up, meaning this whole term is being multiplied by all of this. And when we write as a fraction, when we distribute it in, this is going to line up with the numerator of the smaller fraction, and this is going to line up with the denominator. So first when we do this, and then we can work with multiplying by the conjugate. So when we multiply this, the root 3 distributed into here, the root 3's will cancel and we'll be left with 1. And then for the next one, if we do root 3 times 1, that's, or another way of saying it is root 3 over 1 times 1 over 1 is just root 3. So I have a plus root 3. And then down in the denominator, when you distribute the root 3 in, root 3 times 1 will give us root 3. And then the root 3 times 1 over root 3, the root 3's cancel and we get a minus 1. So now we want to multiply by the conjugate of the denominator. If you want to, you could rearrange these two terms so that they're in the same order as these. So we'd have a root 3 plus 1. I'm assuming that most students wouldn't make that adjustment. So I'm just going to go with it as is and just kind of grind it. Not that it's much more difficult. It's just as you FOIL or distribute, it's easier when you have your terms lined up. Just kind of like if I have x plus 1 times x plus 2 times x plus, if I have x plus 1 times x plus 2, that's easier than x plus 1 times 2 plus x. Top root 3 plus 1. Now we're going to distribute in. So we'll just go term by term. Actually, let's just do the denominator really quick. I like doing the denominator right away because it's pretty straightforward. It's just first and last terms, middle terms cancel, so you only have to do first times first. Root 3 times root 3, and then last times last. Negative 1 times 1 is negative 1. So that will obviously give us 2 in the denominator. Okay, so now let's multiply in the numerator. So I have root 3 times 1 gives us a root 3. Then root 3 times root 3 gives us positive 3. Now we're going to distribute the 1. 1 times 1 is 1. And then 1 times root 3 gives us a positive root 3. Simplifying further in the numerator, we have like terms of root 3 plus root 3 is plus 2 root 3. I'm going to put that term second. It's fine if you put it first or second. And then you also have the like terms of 3 plus 1, which gives you 4. And the denominator, you have a 3 minus 1, which gives you 2. There are factors of 2 in all of these, so we can reduce. 4 over 2 reduces to 2 over 1. And then 2 over 2 reduces to 1. So that would be a 1 root 3. We have a 1 in the denominator, so we don't have to write the denominator again. Simplifying cosine x minus 2, we are going to use our cosine difference formula, which goes cosine of alpha, which is x, times cosine of beta, which is pi over 2. Cosine difference has a plus sign, and then we have sine of alpha. In this case, alpha is x, and then sine of beta, which is pi over 2. Now we can do our unit circle calculation. So cosine pi over 2 equals 0. If I do, I'll just go ahead and write it out. Cosine, you don't have to do this step. 0 plus, in my opinion, you don't have to. Another teacher may require it. Sine pi over 2 equals 1. Cosine 0 goes away, and then sine x times 1 is just sine x, and you are done. So now we're working on the right-hand side. Disregard this box. This is a formatting error when this was converted to PDF. So when you have your sum formulas, we look at this, and this is cos alpha, cos beta, plus sine alpha, sine beta. You want to recognize, your goal is to recognize which of the 6 of the sum and difference this is. And if we have cos plus sine, that's cosine difference. So that tells us this would be cosine of alpha minus beta. So what we need to do is recognize what is alpha and what is beta. So we see in both of these that sine or alpha is 65 and that beta is 5. So we're simply going to take 65, plug it in for alpha, and 5, and plug it in for beta. So we have cosine of 65 minus 5, and I'm not writing the equal sign, just writing out what we're trying to accomplish here. And then if we can simplify, we simplify. So 65 minus 5 is 60, and then cosine of 60, that's a unit circle that we can calculate as just 1/2. Number 4 is exactly the same idea. If we have sine alpha cosine beta minus cosine alpha sine beta of the 6, that's our sine difference, because sine difference goes sine cos, and cosine has a minus on the inside. So over here we have sine of alpha minus beta, and we look back over here, we have alpha is 60, not 60, 80, and then beta is 50. Sorry, those are not the nicest arrows. So if I take my formula here and I plug in 80 for alpha and 50 for beta, then we just simplify as best as possible. 80 minus 50 is 30. Sine 30, we can calculate that. That again, as we had in the first one, is 1/2. Next we have tangent. Tan alpha plus tan beta over 1 minus tan alpha tan beta. And note, you could interchange alpha and beta. So in this case, hopefully you see that alpha is 115 and beta is 125. It also lines up properly in the denominator. If we have a plus and then a minus, that's the tangent plus formula. So we have tangent of alpha. Tangent alpha is 115 and beta is 125. Note, if you flip those around, quite obvious here that if you had 125 plus 115, that's the same as 115 plus 125. Add those together and we get 240. 240 is a 60 degree in the third quadrant. So that would be the reference angle. 60 degree is 1/2 root 3 over 2. So y numerator over x numerator is root 3, and root 3 over 1 or root 3. Tangent's positive in the third quadrant, so you're done at root 3. The directions say find a double or half angle formula to calculate this. We didn't do the half angle formula, so you're obviously just going to look for a double angle formula. Since the double angle formulas use theta, I'm just going to use theta. So if I have cosine squared minus sine squared, that is one of the 3 of the cosine double angle formulas. So you look at that, we see that theta is 15. So now we are going to plug 15 in for that, which would give us cosine of 2 times 15 degrees. And then we simplify. 2 times 15 is 30. Cosine of 30 is root 3 over 2. Moving to the back side, when you do these calculations, you're going to have to draw a triangle for x and y. So I suggest drawing them on 2 different coordinate systems. For the x, it's a quadrant 1, so I'm going to draw my triangle in quadrant 1. X is our angle, as it says sine x. Opposite is 3, hypotenuse is 5. You can either use Pythagorean theorem, or that's a family, the 3, 4, 5. So we have a side of 4 for the adjacent. For the y, it's in quadrant 2, so I'm going to draw a triangle. Remember, going over x and then up y. That makes sure you draw your triangle. That helps to make sure your triangle is drawn properly. And in this case, our angle is y. Sine 12 over 13, so opposite is 12, adjacent is 13. That's a 5, 12, 13, so our adjacent is 5. Note, it's moving to the left, so therefore x is negative, so we have a negative 5. Now we use our formulas and plug in our ratios accordingly. So the first one is sine x plus y, our sine sum formula. You can simply look at your sum formulas. We have sine x, cosine y, cosine x, sine y. So first one is sine x, so I go to my x triangle and I go 3 over 5. Sine of x is 3 over 5. Note, it's not sine 3 over 5, it is just 3 over 5. If you wrote sine 3 over 5, that means what is the opposite over hypotenuse of a 3 over 5 rotation? 3 over 5 is not a rotation in this case. It is a ratio, so we just want 3 over 5. So again, our sine sum formula, the right-hand side of it, that's what we're working out right here. Sine x, cosine y, so I have to go to my y triangle and do cosine, which is negative 5 over 13. And now we do this right here is cosine x, so I go to x and I go adjacent over hypotenuse, which is 4 over 5. And then we do sine of y, this is sine y, so I go to y over here and I have 12 over 13. Note, it's also given. So we just simplify. Here, multiply cross, negative 3 times 5 is negative 15, over 5 times 13 is 65, plus 4 times 12 is 48, over 65, and combine, add the negative 15 and the 45 gives us 33 over our denominator of 65. Moving on to cosine x plus y, I'm going to write out my parentheses. That's cos minus sine sine. Remember, that's the cosine sum formula. So again, this is cos x, cos y, minus sine x, sine y. So cos x, I'm going to go over to cosine of x right here would be adjacent over hypotenuse, which is 4 over 5. Cosine of y, come to this triangle, cosine of y would be negative 5 over 13. Here is sine x, so I go here, I go 3 over 5, and again that was the same as the ratio given. And then sine y would be 12 over 13. And then we simplify. 4 times negative 5 is negative 20 over 65 minus or plus negative 36, 3 times 12 over 65. Subtract, so you have negative 20 plus negative 36 gives us negative 56 divided by 65, and that's our final answer for cosine. So as we come to tangent sum, this would be the same as sine over cosine. So if I sine of this, sine of x plus y over cosine of x plus y would give us tangent of x plus y. So if I did this divided by this, the 65s would cancel and we should get 33 over negative 56. Let's see if that works over here. You may say, Mr. Fossey, could I just do that? If you calculated those two already, however, on a test it may just ask tangent sum, so therefore it's important that we do know how to do the tangent sum formula. Tangent sum, the right-hand side of it is tan x plus tan y over 1 minus tan x times tan y. So now we come back over here. Tan x, that's our first ratio, which is right here, tan x. I come over to x, I do opposite over adjacent, it's 3 over 4. Next ratio is tan y right here, so I come over here, y is 12 over negative 5, so negative 12 over 5. Once I get those two ratios, those go down here, since these are the same, so 3/4 goes there, negative 12/5 goes right there. So I have 3/4, negative 12/5. And now we can simplify if you want. We could go 3/4 plus negative 12 over 5. I'm just going to simplify that bottom fraction. 1 minus, let's see here. So we have a negative 1 times 3 times negative 12 is positive 36 over 20. And we have the complex number set up here where we have to find the LCD of the smaller fractions. And our LCD of 4, 5, 1, remember there's 1 over 1, and 20 would be 20, so I'm going to multiply top and bottom of the large fraction by 20. And if you want, I can do a dotted form just so we see that's 20 divided by 1 to help you kind of line up stuff. Or you just write it as over 1. So into here, 20 divided by 4, that reduces to 5. 5 times 3 is 15. And then if we do 20 into here, 20 divided by 5 is 4. 4 times negative 12 is negative 48. In the denominator, 12 times 1 is 20. And then 20 times, I think I said that right, 20 times 1 is 20. 20 times this, 20 is canceling, you're left with 36, excuse me, so I have plus 36. I'm just going to work up here. 15 minus 48 is negative 33, divided by 20 plus 30 is 56, and if we check, did that match up? if we did y divided by x, that divided by that would give us what we have over here. So that works. Alright, last set of problems on the review. So given the sine theta ratio, I'll draw it over here. We're in quadrant 2, so we draw our triangle in quadrant 2. We put our theta here. 7 over 25. Adjacent side is 24 negative. We move to the left. And now we use our double angle formula. So sine double angle formula is 2 sine cosine. So first off, we have sine of theta. Come over here, sine of theta is 7 over 25. Cosine of theta, which goes right here. Cosine is negative 24 over 25. Adjacent over hypotenuse. And then we multiply. In the numerator, we have 2 times 7 times 24, which gives you negative 336 over 25 squared, which is 625. That's not reducible. Next, we have cosine 2 theta. I'm going to do the first formula, which is cos squared minus sine squared. So first we have cos squared is cos is of theta. Cosine of theta is negative 24 over 25. So we plug that in. Negative 24 over 25 minus sine squared. Sine theta is 7 over 25. So 7 over 25. 24 squared is positive 576 over 625, which is 25 squared, minus 7 squared is 49 over 625. And when we combine the numerators, that will give us 527 over 625. Last one is tan 2 theta. So tan 2 theta formula is 2 tangent over 1 minus tan squared. Tangent theta is opposite over adjacent, negative 7 over 24, and then negative 7 over 24 goes in for there as well. And now it's a matter of simplifying. In the numerator, we have 2 times negative 7 divided by 24. Another way you could do it is 2 over 24 reduces to 1 over 12. So now we have negative 7 over 12. 1 minus squaring that will give us 49 when you have 7 squared over 576. Now multiply by the LCD of the small fractions. In this case, it's 576. I'm going to multiply the top by 576, the bottom by 576. And that's going to give us, first, as we distribute this in, 576 over 12 reduces to 48. So now I'm going to do 48 times 7, which then gives us negative 336, divided by 576 distributed in to both of those. 576 to the 1 is 576, minus 576 into here cancels. We have a 49, and then we go ahead and subtract them. So will give us negative 336 over negative 336 over 527, and that's your final answer.